was the expansion. It stands for Independent Regional Navigation Satellite System. So that's the expansion of the abbreviation, Independent Regional Navigation Satellite System. And what does it do? The most important thing is this: accurate position information services. Yeah. How do we better know this as? We better know this as, in common parlance, we better know this as GPS. Yeah. I'll tell you an interesting fact about GPS, because GPS is kind of become synonymous with position services. A little bit of history about it towards the end of the slide. So it provides accurate position information services for users in India and region extending up to 1,500 kilometers from its boundary. If someone asks you what is the primary service area, and they say the primary service area of Ir Nss is limited to the Indian boundary, the answer is incorrect. It is not just limited to the Indian boundary, it is 1,500 kilometers from the Indian boundary. Yeah. So look at it this way: Ir Nss has two areas in terms of areas, a primary service area and an extended service area. The primary service area itself is 1,500 kilometers from the boundary. And any idea how far is extended service area? Extended service area is really massive. If you look at it, 30 degrees south to 50 degree north. Okay, 50 degree north, which means way above the northernmost point of India. 30 degrees south, way below the southernmost point of India. Longitude 30 degree east to 130 degree east. This is, if you visualize it and if you try to plot it on a map, this is how it will look. So I want you guys to just focus on this area. So this entire blue box that you see over here, yeah, this is the extended area for Ir Nss. And this is supposed to be India's answer to the global positioning system, or India's own GPS, so to say. So this is your extended service. The standard service is something like 1,500 kilometers away from the Indian boundary. Yeah. So you could call this as the standard service area of Ir Nss, and the square is the extended service. Now this is in terms of area. Now in terms of who can use it, yeah, in terms of who can use it, there are two kinds of users who can use it. Okay, there are two kinds of users who can use it. One is the common user. When I say common user, we call it as the standard positioning services. Yeah, I may have missed writing it here, but one is called as the standard positioning services, which is for the common people. The second one is an encrypted positioning services, which is primarily for military and defense purposes. So in terms of area also, there is primary and extended service area. In terms of usage also, there is a standard positioning service and an encrypted positioning services for military and intelligence application. So the resolution of Ir Nss is about 20 meters. So 20 meters is something in which you can easily figure out troop deployments, for example. Yeah. Now, is Ir Nss one satellite, or is it a set of satellites? As it turns out, Ir Nss is a set of 7 satellites. 7. Yeah. 4 in geosynchronous orbit and 3 in geostationary orbit. It would help if you can remember this. And I'm going to show you a picture which will help you to make it easy. Now let me show this picture for once. Yeah. So this is the view of the constellation, 7 satellite constellation. The black color, this one, 1, 2, and 3. These satellites are in the geostationary Earth orbit. So what does geostationary Earth orbit means? They are directly on top of the equator. They are actually on top of the equator. And geosynchronous orbit, now the red ones, they are the ones which are on top of India. 2 sets on the eastern part of India, and 2 numbers on the eastern part of India, 2 numbers on the western part of India. Now, please try to imagine this. All these 7 satellites are moving exactly as the same speed as that of Earth. As a result of which, what happens? All the time, 24/7, all 365 days of the all 365 days of the year, they are able to provide information for this massive area. Are you able to see this? Now you may think, it's possible, you may think, India is well into the northern hemisphere. Why do we need a facility to watch almost till Australia? You may think, yeah, it makes sense that we go up to 50-degree north, because why? It covers entire of China, which is our major adversary now, and it maybe helps us to go a little towards east. Probably, maybe we may want to just have a watch on South China Sea also. But why should we go so much deep into the Indian Ocean? The answer to this lies in India's ambition in the future to test even longer range intercontinental ballistic missiles. Please note this point, because currently the official word is Agni, is the ICBM Agni is 5,500 to 6,000 kilometers. Maybe unofficially it's more, but officially that is the range. Now it's possible that we may extend this in future. Now, which part of Earth will you use to test a missile which has a range of 8,000 kilometers? Yeah. So the only area where you can freely use is maybe start from Wheeler Island and send the missile all the way this side. And when a missile is in motion, then it is in constant communication with the satellite. And Navik is able to accurately track the missile all the way up to 30-degree south. So there is a lot of thought that has gone into having an extended service area for Navik. Not just is it a GPS positioning system for India, but it also has an additional military application, intelligence application, and being potentially being used to track missiles which will have very long ranges in future. Now, you may think that why does India need its own global positioning system? We already have a global positioning system, but many of us don't realize that when we say GPS, global positioning system, it is a set of satellites of the United States which provides services to citizens all across the world. We don't even realize there that GPS is not the only navigational system. Russia has a system called as GLONASS. European Union has a system called Galileo. China has a system called Beidou. So there are multiple, all these major powers have their own global positioning system, and it was only felt that India should also have it. Now, India has also faced the brunt of not developing its own GPS and depending on the US. It is told that during Kargil war, when India sought the GPS coordinates of certain positions on the various mountain ranges, United States had refused to provide them. That was a wake-up call for India to realize that should a hostile situation arise again, it is foolhardy to depend on a foreign nation. It may be friendly otherwise, but you never know. Therefore, there is nothing better than having your own navigational system. Okay. Now, the other interesting part, so that's on the military application. The other interesting part is, if you look at it these days, two-wheelers, four-wheelers, many of them have inbuilt Google Maps and navigation system, if you have observed. Even two-wheelers are advertising having a navigational system. Now, as per AIS 140, so AIS 140 is one of the standards for these electric vehicles, especially. They have to be NAVIC compliant as far as vehicle tracking is concerned. What it means is, just as you choose GPS, you can also choose Navic in these vehicles, and that will kind of help you with navigating the cities or wherever you go. And because that has been made compulsory for all commercial vehicles in India from 2019, and not just the vehicles, some of the mobile phones are also Navic compliant in India. Qualcomm and ISRO had recently signed an agreement in this regard. Yeah, so this was the part which I said many of us may not realize it, but GPS is actually a set of 24 satellites and land control stations, which is available worldwide for civilian use. But then when you ask it for military purposes, it may not be granted, as had happened in the case of Kargil war. So that's about Ir Nss. And yeah, one thing I forgot to tell you, while these the black ones, the geostationary satellites will appear stationary, will appear exactly stationary vis-a-vis India, but these geosynchronous orbit, these 4 satellites, because they are not on the equator and they have a slightly elliptical orbit, not exactly circular, slightly elliptical orbit, and as the plane to the equator, they appear as traveling in the number 8. So this is how they appear. Means the satellite, it appears for a person at the ground. If he watches the satellite appears to be tracing the number 8, which is what is shown here. If you see carefully here, this is what is shown as 8 here. You see an 8 here and you see an 8 here. But that's not the case with the geostationary orbit.